Okay, we're looking at matching tables with equations. So, what this question is asking us to do is match the appropriate equation with the appropriate table. So, in order to figure out which goes with which, I just substitute in the values for x and see if I get the appropriate value for y. So for instance, in this table, I can see that when x equals 1, y is supposed to equal 3. So I'm going to go into the equations and plug 1 in for x and see if y is 3. So if I go up here to this first one, 4 times x, well, that would be the same as 4 times 1 plus 2. And I can see that that equals 6, which is not equal to 3. So it cannot be the right equation for this first table. Try the same thing over here with this one. If I put in, so this is 4 plus 2 times x. Now since I'm trying to figure out if x was 1, I'll put a 1 in here. 2 times 1 is 2, plus 4 again is 6, and 6 again is not equal to 3, which is what I'm looking for because of the 3 that is y here. So I'm guessing it has to be this last one, but we're going to check it to make sure. This says 3 times x, so if x was 1, it would be 3 times 1 is 3, which is what we're looking for. So therefore, this first table matches equation C. Now we go over to this next table, and I can see that here they said when x is 0, y is 2. I already used C, so I'm just going to look at A and B, and I'm going to plug 0 in for x and see if I actually get 2. So if I go over here to equation A, I would go 4 times x, and this time I'm seeing if x was 0, so I would go 4 times 0 is 0, plus 2 is 2, which matches there. So I'm guessing that this is equation A. Just to be sure, I will check by going 4 plus 2. Again, I'm going to put in 0 for x. 2 times 0 is 0, plus 4 is 4, so it does not match that table. But when x was 0, y was 4 for this table, which matches here. So this is equation B. So again, when you're trying to match an equation with a table, you can just plug in the numbers to your equation and see if they match both your x and y value for your table. Then it asks us what's the coefficient. Well, we know that the coefficient is the constant rate of change for the value of y as x increases by 1. So here I can see that x is going up by 1 and y is going up by 3. When x goes up by 1 again, y again is going up by 3. Therefore, the coefficient is 3 because it has a constant rate of change of 3. If I came over here to this table and said, what's the coefficient? Again, I'm looking for the constant rate of change for y as x increases by 1. So x goes up 1 and y goes up here 4. When x goes up 1, again, y goes up by 4. So the coefficient or the constant rate of change for this table is 4. When I come over to this last table, again, looking for the constant rate of change for the value of y as x increases by 1. So when x goes up 1, y went up 2. When x went up 1, y again went up 2. So the coefficient is 2 for that equation. Now we're going to go back and look for our y-intercepts. Remember that the y-intercept is the value of y when x is 0, because that is where the graphed line is intercepted by the y-axis. Just to sketch a picture of what I'm talking about there is if we have a little graph, if we want to know where a graphed line intercepts the y-axis at, it will always be when x is 0 because that is on the y-axis. So to figure that out, I just need to look for the value of y when x is 0. In this first table, there is, they have not recorded if x was 0, so I'm just going to add it up here. To figure out what y would be, I'll just follow my pattern backwards. So I can see that it's increasing by 3. So if I go backwards, I would just want to decrease by 3. And 3 minus 3 would be 0. I could have also plugged it into my equation of C and went 3 times 0 is 0. So here my y-intercept is 0. When I go to this equation, again, the y-intercept is the value of y when x is 0. So I can see that x is 0 when y is 2. Therefore, my y-intercept is 2. Again, y-intercept is the value of y when x is 0. On my table, I can see when x is 0, y was 4. Therefore, my y-intercept is 4.